Alright, hello everyone. Welcome to the second installment in the new series, Understand C++. So, in this video, I'll be teaching you guys a little bit about variable declaration in terms of numbers, and then we'll be making a small, easy calculator at the end of the video. So, this will be just an introduction video, so I don't expect it to be too long. Um, yeah, let's get started. So let's go into Dev C++ and create a new project. Uh, we'll just be calling this as calculator test. There we go. Call it whatever you want. It doesn't matter. Um, then we're gonna once again we're gonna do this exact same thing that we did in my last video, and we're gonna include the namespace, the standard namespace in C++. That just lets us make use of the cout, cin commands in C++. So that's pretty cool. So this is not only a calculator test, it's also good. This whole tutorial today will be teaching you guys about variables and about how to get variables from users. So this is like the foundation. Do not miss this one. So anyway, I'm glad that you're all here. Once we're in here, we're gonna go into our main function. So remember, anything that's in between these two brackets, this opening bracket and this closing bracket, this is our main function. This is our whole actual program, what our program is gonna do. So in here, we have to declare something as well, we have to declare a value as something. So what does that mean? That means that I want to have x. Well, what does x mean in math? X can mean anything. X just means a number along the x-axis usually. And what's the x-axis? The horizontal axis. That's what x usually means. So we want something like that, where it can change based on what the user puts in, and yeah, we want to basically tell x to be that it will be a number, not a type of a word or something. So how do we do that? Well, in order to declare x as any whole number, we can type in int and then x. Now, the variable x is declared as any number, any whole number. So for if you want a more in-depth guide into what integers and a bunch of other variable declarations is, if you want a way more in-depth guide into what they are, then I suggest watching Nico's video, which will be on the screen right now in like a little card thing on the side, and it will also be in the description and at the end of the video. So anyway, let's continue. So int x. Now what we did is we declared x as a whole number value. So let's say that we want to make, so now we know that the variable x, which is what we called our thing. Remember, keep in mind, we can call this anything. We can call it pizza, we can call it Taco Bell, we can call it like number. But for the sake of this video right now, let's just call it x. So we declared x as any whole number. So now, what is that value for x? Well, right now it's nothing. Like it's non-existent. So C++ doesn't know what it is. So let's just assign a quick value to it. Let's make x equal 5. What this does is it sets the value of 5 to the variable x. So x now becomes the number 5 pretty much. So now let's just see if what will happen if we try to print out x in the console after we declare it as 5. So in order to do that, just like we did in the last video, cout these two arrows going this way, and then we can just type in a nice statement to make it all nice. The number is, and then these two arrows again to continue it, x, end line. It's always just good practice to end line at the end of your program, just because I like to do that. I don't know, it's habit. Anyway, let's see what happens when we run this. So once again, compile it and run it, and then save it as whatever you want. I'm just going to leave it as default. And see, the number is 5. So let's just cross-reference that with our code to see if that's indeed what we should get. We're going to print out everything in the green just the way it is. So the number is 5, the number is colon, because that is the message that we want to display, and then x. So remember, we set x equal to 5, and that's why it displayed it as 5. Now, I know what you're all wondering. What if we do have a number that is a decimal, like that has decimals in it? So let's say that we do like negative 5.8. Remember, integers can be any negative or positive number. It doesn't matter, but it has to be a whole number. If we do a decimal, then you'll see what C++ does. It's pretty cool. What it actually will do is it'll ignore everything behind the decimal. So it'll just ignore all of this. It won't round it at all. It'll just ignore everything behind the decimal, because and then only save the first number, the number before the decimal. So as you can see, instead of printing out the number is 5.8, C++ decided to print out the number is -5. So that's just pretty cool to keep in mind. So now let's say that we want it to be we want it to be able to store decimals. Well, how do we do that? We have to declare x as something else. We cannot declare it as an integer anymore, because remember, integers are any real number that is a whole number. It cannot be a decimal number. It can't have a decimal place in it. It can be 1, 2, 3, 4, 5, but nothing in between. So how do we change it to include decimals? Well, instead of declaring it as an int, we declare it as a double. And what double basically does is it allows it to hold decimals. So now, when we run the program, we should expect the number to be -5.8. And that is indeed what we get. So we know that that is successful, and that is what integers and doubles do. So now you might be wondering, why don't we just use doubles all the time? What's the point of even using ints when they're just limited? That is true. Integers, declaring something as an integer basically just limits it, but what it also does is it helps on efficiency. Doubles use a lot more space than declaring something as double uses a lot more space than an integer. So if you're writing a huge program where efficiency is important, then try to use doubles only when necessary. It's much better to use ints and then booleans. In this video, I won't really go into booleans and more into what the exact values, like the exact ranges for these declarations are. Nico did a great video on that. He did it in Java, but once again, it's the exact same thing. Like the declarations are the exact same as in C++. So anyway, great, we have this. So let's just quickly get rid of this. Now let's start over and let's try to make a quick, simple addition calculator. A calculator that just gets two numbers from the user and then just adds them together. So how do we do that? We want to include decimals. I'm going to include decimals into this calculator, so I'm going to declare my shit as double. So I'm going to declare the first number as number 1, and then if you want to declare a second number, you can also skip to the next line and then declare it here, so I can declare it as int number 2. But if I do that, then this one will have to be an integer, so I want this one to be a double. And then if these two variables are being declared the same thing, you can also just put them on the same line and then separate them by a comma. This will also declare number 2 as a double as well. So putting it on the second line is the exact same thing as just putting a comma and putting it here. It doesn't really matter. I prefer to have it all in one line. Some people like to space them out in different rows, but I don't know. I prefer to have it here. Do it whatever way you see fit. So anyway, how many variables do we need? Let's just think about it. We're getting two numbers from the user, and then we're putting out the answer into the console. So we need a variable for number 1, the first number from the user, a variable from number 2, the second number from the user, and then a final variable which will also be a double, which will be the answer. Now remember, if we made the answer be declared as an int, then what will happen is the decimals being added here will just be ignored, and then it won't be displayed in the answer. So let's say that I have like 2.5 and then 3.1. Well, let's add them. We get 5.6. But my final answer will only display 5 if it's left as an int. So I also need to keep this as a double. There we go. So now let's just get our values from the user. So cout, just do a nice opening statement, an opening message. Please enter number 1, colon, and then I want a space, and then I want him to enter it on the same line, so I'm not going to do the end line command. And cin number 1. Good. And now let's just do it, get the exact same thing, but for number 2. So cout, please enter number 2. Again, on the same line, and then cin number 2. Now keep in mind, doing this will actually also go to the next line, because after you type in the number 1, like after you type in the number 1, it'll automatically jump to the next line by the next cout command. So I don't have to do an end line at the end of this, or I don't have to go and make another cout end line for no reason. C++ already thought of that and decided that that's always going to be the case where people want to have it on a different line. So yeah, let's just go right into it and then see what happens. What will happen when we run this? Well, let's see. We'll just be prompted to type in the two numbers, so negative 9.8. But then nothing else will happen. The program will just exit. Why? Because we didn't tell it to do anything. Oh, wow. Silly us. So anyway, now that we have the two variables for the numbers, we want to set the answer equal to whatever they are added together. So answer equals number 1 plus number 2. And then semicolon at the end to end the line. And then let's just print out the answer. The answer is answer. So now what will happen when we run the program? Let's just go through it in our head first. It's going to display the message, please enter number 1. We're going to get the value of number 1. Please enter number 2, get the value of number 2. And then we're going to add those two numbers together, and then the value, whatever that value is, we're going to store it into another variable called answer. Then we're going to print out the variable called answer. So let's just do something simple. Let's just do 1.1 plus 1.1. Just so that we can see what's going to happen. It's going to be 2.2. That will be the final answer. The answer is 2.2. So now you might be wondering, what if we do subtractions? Will it still add? Well, yeah, think about it. If you subtract the negative, that's just the same thing as doing a subtraction. So if we do, for our first number, 5.6, our second number can be negative 2.4, well, that'll be 3.2. And the answer is 3.2, because we just added this. 5.6 plus negative 2.4 is the same thing as 5.6 minus 2.4. So that's that. So it works with negatives, works with positives. Anyway, this is the first little beta test of our calculator. I hope you guys learned something from this video. This was a pretty informative one. In the next episode, we'll be doing if statements. And then at the end of that video, we'll actually do like a full-on calculator with multiplications and divisions and additions and like actual subtraction commands. It's going to be lit. So I hope you're all excited for that one. Anyway, thank you for watching, and I shall see you again in the next video. Remember, if you want a more in-depth look on what variables are, including booleans, which I didn't really cover in this video, but we will be using it in the episode later on, just because of its efficiency, please check out NeetCode's video, which link will be in the description, and there'll be a little pop-up on the screen right now as well. So anyway, thank you for watching, and I shall see you again in the next one.